library code in our homebrew application, which is done by default anyway, and fix the image space to some place in the game memory that's not occupied. And after that, attach our homebrew application to the game executable and fix the header in the game.do file to reflect the changes. And the entry point will be changed to the entry point of the homebrew. And after the homebrew finishes running, the execution will be transferred to the game, which requires a small jump patch in the executable code. And there's also a place in the homebrew that causes problems. So after making those last fixes, all you have to do is pack it back neatly into a game ISO file and distribute it to the public using torrents or POP or whatever you like. And there's a small tool I made that semi-automates the injection process, and I'm not trying to give you like a full walkthrough of how to create Wii malware, but just to give you guys an idea of how it works, I'll show you a little demo. First, you have to extract all the files out of the game ISO file, which I won't show you because it takes more than 5 or 10 minutes. And my favorite tool for that purpose is WIT, and this is the extracted game image, which is Okami extracted. We use Okami here for the example. And normally the main do file is at the sys folder, so finding that main do and copying to the injector tool directory right now. And you can see that main.do file right there. That has all the game code in it, so we're gonna copy it. Well, it's already copied to the injector directory, so moving on to the injector. The injector needs 3 files and 3 addresses to work correctly. So, and these addresses can be found in IDA. So we fire up IDA and load up the homebrew. This is the assembly code of the executable code of the homebrew file. I'm gonna skip all the analyzing part, and this address right at this part, this is a branch instruction, and that branch is the last branch taken before the system completely shuts down. So we're going to use that branch as a trampoline to the game, to the actual game file. So that's going to be the first address. Then this part of the code writes to someplace outside the game address space. So it's writing to an invalid memory. I don't know why it's doing that, but I tried noping, removing that whole part out, and then there was no problem running the homebrew. So I just nope that whole part out. And that's the starting address of that code section is going to be the second address. And the third address is going to be the image space of the game.do file. So we're going to open the game.do file in the hex editor. and the entry point is at a fixed location in the DOE file, and the DOE file format is pretty much publicly released. So that fixed location is E0, which contains the D-word 8000403C, and that's going to be our third address. And so yeah, you first write the file that's going to be injected. To the resulting file, the file, the homebrew application. And then you write down the resulting file that has the injected data in it, and then you write down the three addresses that we just found before. And I don't quite remember the addresses, so I can't quite write it down here. But that's how this injector works. And after you execute it, you have a main DOE file that has the injected code in it. And all you have to do is put that resulting main DOE file in its original place in the game image, and then you repack it into an ISO, and then all you have to do is distribute it to forums or torrents and places like that, and people will download it, and hopefully, not hopefully, but they will accidentally have malware running on their game systems. So that's it for the demo.